I have 11 Dependabot PRs open right now. One of them has been sitting there for weeks, a major version bump on a side project, and I've never made the time to figure out whether it actually breaks anything. This is actually the perfect job for a software factory. Agents working through the queue instead of you. But the hard part isn't the LLM, it's all the plumbing around it. Today I'm building the piece that matters the most, an isolated sandbox that the agent can actually work in using Mastra and Railway. If you're new to the channel, my name is Damien, and I've been a software engineer for over 15 years. During that time, I've led and scaled teams from 0 to 50, shipped regulated software in the software as a medical device field, and now build agentic systems. On this channel, I share what I've learned building with AI. Before we get started, I want to thank today's sponsor, Mastra. Mastra is the TypeScript framework for building agents and AI systems. Today's system is built entirely on top of it, and this past week they've even shipped their own pre-built software factory. Worth checking out. Today we're building ours by hand, because the interesting part was never the factory, it's deciding how much you hand it. Links will be in the description for everything, as well as the code for today's build. Now, let's get started. First, an overview of what we're working with. If you missed the last video, here's what we've built so far. First, we have a Mastra agent called the triage agent. Its job is to review Dependabot PRs as they come in and decide whether or not we can merge them. Second, we have a GitHub app. It has read access to pull requests and fires the webhooks that trigger our Mastra workflow. Finally, we have a Mastra workflow that ties everything together. It goes ahead and fetches the details of the pull request, finds a dependencies changelog through the RubyGems API, and posts a card to Slack through the Mastra channels integration. That notifies us whether the PR can be merged, whether it needs to be held, or it needs further review. All this worked well, but everything it knew came from reading the changelog. It never actually looked at our code. Today we'll go beyond the changelog. The agent is going to work out whether a dependencies changes can actually reach our code and whether our tests would catch it if they did. Then tell us whether it's safe to merge or not. To do that, it needs somewhere to work, a sandbox. A sandbox is an isolated environment for our agent to work in. The agent can change our code, delete a validation, break something on purpose, and run the application and verify it's all working, all without touching any other system. For this, we'll be using Railway. They're not a sponsor, but I've used them a lot in the past. I've also included an affiliate link in the description where if you use it, you'll get $20 in credits, enough to follow along for free. Railway gives you the sandbox as a blank Debian machine. Anything the app needs, a language runtime, a database, you have to install yourself. These can be time consuming. For web, that's going to be Ruby, Postgres, and running bundle to install all of the gems, as well as cloning the repo. You don't need to pay that on every single pull request. Once a sandbox is set up, Railway lets you snapshot it. Every audit after that boots from the snapshot instead of rebuilding the entire image, making it much faster to get started. The repo will already be cloned, and the main core gems will already be installed. Every pull request gets a fresh one, and it's gone when the audit finishes. This means that every run has its own test database and own entire application stack that it can run your application inside of. Now, let's dive into the code. So before we get started, let's talk about the primitives that Mastra gives us in order to actually accomplish what we're trying to do. So the first thing we need is access to the codebase itself and file access. We can do this through what is called Workspaces with Mastra. Workspaces give your Mastra agents a persistent file system to work inside of. They also provides the sandbox where it can actually execute code, whether that's through a local sandbox, a cloud sandbox, or anything like that. The sandbox that we're going to be using is the Railway sandbox. Mastra actually has built-in support for Railway sandboxes, and we'll dive into that a little bit further, but the sandboxes allow you to have an ephemeral Railway instance to run commands inside of, clone your repo, and have an application stack all fully running. In order to use these sandboxes, you need to enable it. You have to go into your account settings inside of Railway and find the section for Project Sandboxes. Turning this on enables the feature for you. Once this is set up, we can now go and actually use it. So let's take a look at some code on how we're actually going to do that. So let's take a look at our Mastra agent and what we've done so far to change it. So the first thing we can take a look at is line 131, where I've added the workspace argument to the agent itself. Now, this is where we actually inject the workspace. In typical scenarios, you might have a singleton workspace that's available for your agent. But in our scenario, what I actually want to do is I want to have every single run of a PR review for the triage agent to run in its own isolated sandbox. So we're not going to be using one shared sandbox per agent. So in order to do that, the workspace argument actually takes a function that we can call and have it inject or generate the workspace at that point in time. So to do that, we're going to go ahead and inject that in the request context during the workflow step. So that's what's happening here. Now you'll see that we've made a bunch of changes also to the actual agent description, but we'll come back to that a little later to take a look at that. The next piece, let's take a look at the actual workspace itself. Let's take a look at how we create our sandbox and get it started. So here is the workspace.ts file. This is where we're going to construct everything. And as you can see here on line 15, we're describing what that is going to look like when it comes time to build. So every single PR is going to have its own individual sandbox where it can do its audit and change code, run the tests, all at the same time, isolated from one another. And at the end, it's going to go ahead and destroy that sandbox and clean up after itself. We have some rules for some defaults. So we're doing an idle timeout of 10 minutes, meaning after 10 minutes, if nothing's happening in the sandbox, it'll auto clean itself out. That's an important number to kind of keep in mind because you don't want to keep that too high and then waste kind of billing on a sandbox that's not being used. And then we have a concurrency ceiling. So imagine a Dependabot spike comes in and maybe 5 or 10 PRs get open. You have a choice of running up to 10, say, sandboxes all at once, or kind of maintaining that yourself. And so for my purposes, I'm going to have 4 max concurrent sandboxes running to kind of help curb costs instead of having them all run in parallel. And then we're going to keep track of that in this active state. So we're saying let active equal 0. We're using that to track how many are open. And anything that's waiting will be chucked inside this waiting array on line 46. If we keep diving further, we can look at the acquire slot. That's just taking the logic of checking whether we've hit our max concurrent sandboxes or not and incrementing the active number. And line 57, we have a release slot function. That's going to go ahead and just release that slot and pull anything out of that waiting array to handle. Sandbox configured, that's just checking to make sure that we have everything we need to actually run a sandbox. That is the Railway API token as well as the Railway environment ID. You'll need to get those from your Railway configuration to be able to use this. And so the .env needs those files. .env.example in the repo has those in there as well. And you can get a Railway API token from your settings. And we go ahead and inject that as part of the client config. So Railway, like I mentioned, supports templates for its sandboxes, and so does the Mastra Railway integration. So the audit template function is here to generate a sandbox template. A sandbox template is what allows us to define what that sandbox should look like in a reusable form to reduce that timing for when it's being built. So every single build doesn't have to go ahead and say install all of the packages, install Ruby, install all of the base gems, install Postgres. It's all built into that template, which is cached and then can be reused for subsequent sandboxes. And if the template ever changes, then that's going to have to be rebuilt. And so that's all being done through this function here to build it. We're using build steps, warm up steps, and then some run steps to actually execute and install things. And you can see we also have an environment that we're injecting, which is the GitHub build time token. So this is a GitHub personal access token that is configured for read access for the repo that we're working with. You need this to be able to give it access to clone down that repo. That is also in the .env.example and will be needed if you're trying to follow this along. So just generate a personal access token in GitHub for read access to the repo. So let's take a look at what build steps and warm-up steps and the app packages looks like inside of our recipe. So the recipe here is where we're extracting and configuring how to build this image. So we have a Ruby prefix, so where we're going to install Ruby, because basically the Trixie's app doesn't have Ruby 4.0.5. It's kind of at 3.3. So we've gone ahead and we're going to pull down from the Ruby builder repository the latest release of Ruby and install it ourselves. We configure some information like the wef-dir. We're going to chuck that into /app, the clone URL of where to find it. If we go back to the workspace file, we can take a look at the acquire audit sandbox. Here's where it's going to instantiate a new sandbox and use it. So we instantiate a new Railway sandbox. It's going to have an ID of the run ID. And here we're passing it that function for the template. So this is where it's going to use that reusable Railway image template for building it out. And we've set network isolation to isolated, meaning it can't access anything else inside of the network, and some information about the GitHub token. Then we instantiate a Mastra Workspace using that sandbox, and we call it init. Then we have our tracker for what we return, which is going to be the workspace, the sandbox, and then our release function. So let's take a look at the changes to the triage agent's instructions to understand what's been changed as part of this. So now we've updated a lot of it around to understand that it has access to this workspace and the sandbox where that it can actually run and execute commands. So all of these are kind of going through the different verdicts. And then we have the investigation. So it's going to have a 3-phase investigation. Phase 4 runs whenever it applies. Phase 1 is it gets the dependency PR and gets the release note. So the same things that we did in the last version. Phase 2 is, does it reach this app? That's one of the newer pieces and more important. So what it's going to do is for a dropped runtime version, it's going to compare the WEF directories get gemfile.lock and the Ruby version and state both numbers in the reasoning. And then for a changed API, it's going to grep the repo for call sites. So if a API changed, we need to see, are we using that API? Is it a method that we were actually using? And so does that impact us? And for a changed behavior, it's going to identify the code path that would reach it or establish that none does. And so it's going to go through and actually inspect our code and analyze what's there to determine whether or not it's safe. Then for phase 3, it's going to get a baseline. So it's going to go ahead and clear out the RSpec artifact path, and just to make sure that it's cleared any previous evidence that's there, even though there shouldn't necessarily be any. It's going to go ahead and fetch and check out the branch for the actual Dependabot PR. So then finally, phase 4, test the test. So this is required when the bump gem is part of how this app detects problems. Say a test framework or a matcher library, mocking libraries, things like that. So that shoulda matchers example that I mentioned. So if the gem is test tooling, a green suite in phase 3 tells you almost nothing on its own. So, right. So phase 4 is going to go ahead and actually check the evidence for that. And it's going to do that by upgrading the test tooling and make a change to the test based off the changes. So, and then from there, prove whether or not that, the tests are passing or failing correctly or not. So if we remove something that we expect to fail and we get a red, then we know when we put it back, it's green, then we can actually have confidence that the tests actually work. And finally, phase 5 is going to go ahead and decide the verdicts before. So now we've gone ahead and actually are executing the code as part of our software factory. So let's go ahead and run an example of this for 2 PRs that are currently open on Weft. One of them is going to be that shoulda matchers example that I mentioned before, and another is just another gem that has also been upgraded that needs some review. So I've gone ahead and dispatched 2 of the PRs, reapplying it so that we can see what happens. We have the sandboxes here open, and so as those get triaged, we should see multiple instances of the sandboxes. So there they are running in parallel. See, we have 2 IDs for 2 active sandboxes running at the same time. So 2 separate agents running through 2 separate PRs at the same time in their own isolated environments. We can even open the console to kind of see what's been happening inside of here. So if we go ahead and view the output, we can see everything that's happening for, say, getting inside of Ruby on Rails and the packages as well. And so here we can see both of these are running, and we can let that go, and we can see it destroying now that that one is done. So one of the runs is now cleaned up after itself, and that's checkpoint, and that sandbox is now gone. And so the other one is still running, and once that one's done, it will also clean itself out. And there it's gone. So now let's take a look at the output from Slack to see what we got from those 2 runs. So we can see that 2 different PRs were reviewed. One was shoulda matchers, one was Tailwind Rails. We see that shoulda matchers went from 7.0.1 to 8.0.1, and it categorized the risk as low. Only backward compatible note is dropping from Rails 7.1 to /Ruby 3.2, and this app is on Ruby 4.0.5 and Rails 8.1.3. So that break does not apply here. Full RSpec suite passed on the PR. And the probe assertion verified key shoulda matchers validations still fail when their underlying model validations are removed. So it went through and actually made some changes to the code, generating what should be failed test, saw that they failed, and verified that it's good. And so here it's recommended that we go ahead and merge this. And so we can view that pull request from that link. Then we have a Tailwind CSS Rails upgrade from 4.4 to 4.6. Also noting low, release notes only describe an additive option silent and a dev rake task for Tailwind CSS Watch. Signal forwarding neither changes runtime app behavior unless you run those Rails tasks. And we see that we've gone ahead and have a merge suggestion as well. So both of these actually got reviewed inside of the sandbox in parallel and have now been set for approval. So one last thing, let's go back to our workflow and the triage step to see what we ended up changing. So we were looking at that acquire sandbox function that we were talking about before, and that is what gets called inside this triage step now as part of it. So the sandbox is for this PR alone, and we kind of restore that from there. So that's where we get the run ID and we pass it. So run ID is passed to us as a argument to the execute function of create step. Inside of there, we are calling acquire sandbox, and we pass that run ID. And from there, we call our agent, agent.generate. And inside of the request context, we inject that workspace. So that's how we kind of dynamically generate that workspace so that every single run has its own workspace to run against. So that's where the factory is now. It reads the release notes, checks whether the change can reach us, runs the suite, and proves our tests still catch things. If you want to check the code out yourself, there's going to be a link in the description. You can clone it, fork it, and try it out yourself. In the next episode, we're going to build on this even further. We'll give our agent the ability to actually merge the PRs it deems acceptable instead of needing our intervention. So be sure to subscribe to catch it. If you're building something like this, agents doing real operational work, or a factory fitted to your own code base rather than off the shelf, I can help. Link is in the description. I'll see you in the next one.